Next is Hubertus, CTO of Balluff.
Thank you, Sandeep. Also, a warm welcome from my side, and I have the honor today to talk about an industrial perspective in machine learning on the edge. And before I get started, as he mentioned, I'm head of technology at Balluff, but who is Balluff? Who are we? 3,600 colleagues and what we are doing, and therefore a short intro of what Balluff is doing. So we are 100 years old, not me, and we are passionate about industrial automation. And we are doing sensors, we are doing network devices, industrial communication devices, and of course, we can make use of machine learning in a lot of applications. The first one I brought with me, automotive robots. Zach already talked about that example. We collaborated together with Edge and Pulse, with Ready Robotics and our teams in order to get the demo up and running, and it's a vibration sensor on it. But we are also measuring the angle of the joints in such robots. So this is in the robotics industry. We support our customers in the battery assembly, which is, I would call it at the moment, a boom business. We are in energy, wind power. We do measure the variable pitch angle of the propeller blades in order to get the right setup for the right true airspeed. And we will hear about that a bit more soon. We are in the semiconductor industry, for example, measuring the edges of the wafer disks in order to have a centered one in the epitaxy process. So this is where we are. And in the industry, I think we need to tackle 3 challenges. First, we need to solve real-world problems. I think this is a term which is commonly known in the machine learning community. But we also need to decide whether to do the machine learning on the sensor, on the field, or on the edge, or in the cloud. And this is also an always ongoing discussion. And thirdly, we need to create value propositions that count for the customers, that we generate a value proposition where there is also a willingness to pay in the end for such a solution. But let's get started. Solving real-world problems. So I brought 2 examples with me, one from the milling industry, so machine tooling, and one from the automotive. But let's get started with metalworking. So in an industrial environment, like you see it on a picture, we will go into a milling machine, which you see here. And in a milling machine, there's a tool running. And the tool is running and making a job, and the question is how to detect the cutting wear. Because you would be interested in running such a tool if your tool is still okay. And of course, cutting wear, and you see here such a flank cutting in the aluminum, you would like, or you are interested in doing that in situ, so in the process. You can use optical methods, but you cannot use that in the process because you cannot simply see the edge while it is running in the aluminum. And that's the reason why we thought of, okay, how we could tackle that problem. And here you can see pictures, still optically, right? On the left top side, you see a brand new flank, which is doing good, of course. And then you see different stages of wear. And we took one of our sensors, by the way, it's the same that is mounted on the robot in the lobby, and this sensor measures the vibration data. And if you look at the vibration pattern, you can simply see, okay, what can you see? Not much with a bare eye. And this is the pattern of a new tool. And if you now look at the pattern of a worn tool, let's have the click, you see, okay, it's not that different. And this is the moment where we need to use machine learning algorithms to find out with the raw data, where is the difference? And this you can apply. And we made it that, for example, we can classify the information. To train the algorithm in order to classify the vibration pattern to a dedicated worn stage. One solution. The second example I brought with me, if you look at this bodywork here in an elevator in an automotive production line, and you see the motor on the upper picture there in this white frame, it's a little piece of equipment in a whole automotive production, but if this one fails, the whole production is down. And you can imagine when, for example, at Ford, the production line is down, what is of the amount of money lost every minute. So it's important to understand what is the well-being of this piece of equipment. And there as well, we looked into the vibration data, and the upper pattern graph plot shows you the usual pattern. And you can see the different stages of this elevator. You have unloading, where the bodywork comes into the elevator. Then you have the lift section, you have the unload section, the sink section, then it repeats. In the lower plot, you see, oh, there's an anomaly. For example, the first wave shows there is much more vibration difference. So there's something wrong. But you cannot specifically search in such a complex assembly and train the algorithm for specific to be classified cases. You need to detect anomaly. And this is an anomaly where you can say, okay, it's an alert, we should have a look on this motor. Or the second example, on the right-hand side, there is one complete sequence missing. So the bodywork was not unloaded. Also good to find that out. The second chapter is the discussion on premise versus cloud. And if you look at the pyramid of automation, you see here you can have different IoT stacks. So on the field level, you have the sensors, single piece sensors, ranging around 50 to 250 or 800 euros. Then you have the edge level, where you have these edge devices, and we already saw some cool edge devices today from Zach and the Optra team. This is another one here shown, or let me say an IO-Link block for industrial protocols, typically. And you have the cloud level, where you have endless computing and processing power, endless storage, where you can do everything. But in the industry, that's not always possible. And there are differences. If we look at this picture, we're coming back to this milling example. On the left-hand side, the sketch shows this milling tool, if you can imagine. Then we have here the vibration sensor mounted, an edge device, and the cloud. That's the topology. If we can apply a machine learning algorithm on the sensor, and Zach elaborated on that one, you can make use of the raw data because you have the raw data available. You do not have to transport them through a narrowed bandwidth, tiny pipeline you called it. You have the full sensor data from a MEMS element, for example, and vibration data available. We found out that in this special use case, we can have the stage of worn of this milling tool in a 99% accuracy. But if you are not willing to apply the machine learning algorithm because you need processing power, you need storage on the sensor because it makes the sensor itself expensive, more expensive. Then you can also decide, okay, we go with these algorithms on edge level and having an edge device with a Linux system running with more processing power, more storage, also possible. But you have a reduction in accuracy because you do not have all the raw data available for your algorithms. And the same you can do on cloud-based. So you use the edge gateway only to collect the data from different sensors because in some industrial applications, you have tons of sensors, and you can make use of all the sensor data and then apply the data to the cloud and having there the computing power to calculate. The last chapter I want to address today is we need to create value propositions that count. And I brought one example. I talked about the wind energy with me to give you an idea which value proposition could count for such a customer. Houston, we do have a problem. I think it's not hard to imagine how costly such an unpredicted event could be. And this is exactly where you automatically see there's a high value if you have a solution for your customer in order to prevent this unexpected downtime of such a wind energy plant. But if you want to create value propositions, you always need to start with a business model canvas. And you do not need to, in the first moment, not take so much care about the activities, resources, channels, value streams, cost structures. The first thing you always need to do is to understand the customer's problem, and in order to fit that to your value proposition. And pointing these two elements out, customer segment and value proposition, apply that one on our three examples we just discussed. The pitch propeller, here you can see, okay, on the right-hand side, the customer, and the customer's job is to operate these wind energy plants. And a gain creator would be if there is no failure over years, of course. And the pain, you see the tons of helicopters, and you can imagine these emergency missions are very expensive. So if you now have a value proposition applying machine learning, anomaly detection over sensor data to prevent such downtimes, of course, you have a high value. And of course, it's not an issue to apply your machine learning stuff in the cloud, having connections at gateways, all the stuff. Price is not an issue here, perhaps, or more. Second example, the bodywork. Here we have a lot of sensors in such assembly lines, and also looking into the business model canvas in these two topics, you see, okay, a big pain is in line downtime, and you can apply an edge gateway in order to have anomaly detection and early warnings. And the third example we already discussed was the milling tool, also there. But what you see here, you have a machine running, and it's a real-time problem. You need to make decisions and warnings with low latency, making use of all the raw data on high resolution. So here it is perhaps wiser to apply the machine learning algorithms on the sensor to be fast in the field and real-time decision making. When we put this all together, then we see, okay, on a field level, the cost may be low, but of course you need trained algorithms deployed on a sensor. You might send your algorithm, your machine learning algorithm, into a boot camp in the cloud to make him fit for detecting and make him even better, train him even more. You can apply on edge level, but you need to invest more. Or you can have the full IoT stack running until the cloud level in order to have the full computing power. And I think the summary is that not one size fits all. That's the key takeaway for me. If we sum everything up, we need to solve real-world problems. Therefore, we need domain know-how. We need to decide on-premise versus cloud. This depends on the solution. And we need to create value propositions that count. That means we need to understand the customer's job, and we need to design our value proposition for the customer. So, summing all up, I would say, know your problem, have great partners, and build your industrial-grade solutions. Thank you.